We are going to work on electrolysis process, the second part of unit number 12. In electrolysis, there are certain basic components. Electrolysis is not a new word for you. In your grade 9, you studied about electrolysis. Electrolysis using carbon electrodes, electrolyzing acidulated water, things you studied. This one, really, I didn't consider some. Okay. Till people are entering, let's wait 2 minutes. If they come in the middle, so in electrolysis, we are going to create a chemical change. We are going to create a chemical change in an electrolyte. Okay, we are going to create a chemical change in an electrolyte using lacticity. It is the idea. Electrolysis unit is very easy, my children. In electrolysis, these are the basic components. Any electrolysis will have this. There will be a solution. There will be a solution. Keep in the mind. It can be a solution or it can be a liquid. There are two choices. It can be a solution. It can be a liquid. And this solution or liquid coming here is called electrolyte. The name given to it is electrolyte. Inside this electrolyte, you need to put two electrodes. These are two electrodes. Electrodes are connected to end of the battery. You have to provide DC current to do electrolysis. Electrolysis will not happen with AC current. So there are three basic components needed for electrolysis. What are the three basic components? There should be an electrolyte. there should be 2 electrodes and there should be a DC source. Can you please mark this one down? Can you please mark this one down? Roughly draw a picture and mark all of them. Put me a done mark at the end. Put me a done mark soon you complete it. Right. Before we go into the tube, because this is online, so online has certain mindset and methodologies, right? Directly, like in the direct class, we cannot go into the tube. Okay, we cannot go into the tube. We have to do certain arrangements and go. In that way, if you take an electrolyte, in an electrolyte, that solution could have two types of ions. There will be cations in the electrolyte. There will be anions in the electrolyte. There will be cations, there will be anions in the electrolyte. Within the syllabus, these cations are there. Na plus, Cu2 plus, H plus are the three cations that is possible to stay in an electrolyte. Okay. Similarly, there can be anions. OH minus is one anion, Cl minus another anion, SO4 2 minus is another anion. Possible cations and anions I have written here. Possible cations and anions I have written here, right? These are the possible cations. Remember, in electrolysis, cations undergo reduction. What kind of change they undergo? They undergo the change called reduction. During reduction reaction, Na plus, okay, will take one electron and will become Na. Na is plus, no, it will accept one electron and turn to Na. Cu2 plus will take two electrons and will make Cu. H plus, generally H plus will stay in this manner. 2H plus will accept two electrons and will become H2. Are you clear? Are you clear? Only these three you want to know. You don't want to know anything about these three. Only these three you want to know for reduction in electrolysis. Reduction in electrolysis, only three things you want to know. No more. Okay. Similarly, if you take anions, they will undergo oxidation. They will undergo oxidation. If you take these three anions, only these two can undergo oxidation. It cannot undergo, sulfate cannot undergo oxidation. I am writing the oxidation reaction here. 2Cl minus aqueous. Okay, remember all these ones are aqueous. This is a solid, this is a solid, this is a gas. 2Cl minus lose two electrons and will form Cl2 gas. OH minus is little interesting. 4OH minus will form two water molecules. Water is liquid. One O2 gas molecule and 4 electrons. Oxidations, we write reactions on the right side. We write the electrons on the right side. That is oxidation's nature. Reduction electrons are written on the left side. So all together, you need to know 5 reactions to understand the entire electrolysis. 3 reduction reactions you want to know: Na plus, Cu2 plus, 2H plus. 2 oxidation reactions you want to know: Cl minus, 2Cl minus, 4OH minus. Are you clear? Can you understand it? Yes, yes. All these ones are starting, all of them are in aqueous form. Starting, all of them are in aqueous form. Right. You children copy this one in your paper. Get ready for the work. AG not necessary for this. That's why I skipped it. Although it is in the tube for this lesson, it is not necessary. Have you completed it? Have you completed it? Okay. Now we are coming to the work in direct. We are coming to the work in direct. Here we take sodium chloride liquid. Actually, it will be liquid at 801 degrees Celsius. Not easy to do in the school laboratories. Not easy to do in the school laboratories. Sodium chloride liquid mean what temperature? 800 degrees Celsius. You place 2 carbon electrodes here. This is a carbon electrode. This is also a carbon electrode. My children, carbon electrode is an inert electrode. Inert electrode. Because it does not undergo, okay, it is resistant to oxidation or reduction. Carbon will not undergo oxidation or what? Reduction. Carbon will not undergo oxidation or reduction. So it is called inert electrode. Carbon electrode is an inert electrode. Platinum electrode is also an inert electrode. Here we are connecting the positive end of the battery and negative end of the battery to the electrodes. As this is sodium chloride liquid, in this environment, there is Na plus ion and Cl minus ion. Both the ones are in the liquid. Both the ones are in the liquid. Not solution here. Only NaCl liquid is there. Na plus is plus no attracted to the minus. It will go to the minus. Cl minus is minus no attracted to the plus. That is very common. Plus is attracted to the minus. Minus is attracted to the plus. Going to the minus place, Na plus will undergo oxidation. Na plus undergoes reduction. From this electrode, it will get an electron and form Na. Any confusions? If the terminals are changed, Yusuf, this will become minus, this will become plus, then Cl minus will go there, Na plus will go to other side. Isn't it? Isn't it, Yusuf? So this is what kind of reaction? Reduction. Because reduction is taking place here, we call it cathode. Because reduction is taking place here, we call it cathode. Are you clear? Are you clear? Reduction taking place is called cathode. Good. Cl minus come here. Cl minus come here. This is the positive electrode. Positive electrode is electron deficient. Electron adu electrode. Electron deficient, hungry electrode, electron hungry. Want electron, want electron, want electron, want electron, want electron, electron hungry. There are people living in the world with money hungry, no? Yes, Shamla. We are finding it with positive and negative. So this is the positive electrode. This is the negative electrode because of the terminals. So when you now say this is going to a place where electron hungry. So it has to give the electron, it has to the electrode, and it is becoming Cl2 gas. So in this place, you will see there are gas bubbles. In this place, you will see pieces of sodium. This is oxidation reaction. If it is oxidation reaction, this place is called anode. Are you clear? Are you clear? So the picture is already given to you. Only thing you have to do is you have to put the details there. You have to put the details there. You put the details and put me a done mark. Right. If you are done in the tube, in page number 6, you are given 7 questions. See whether you can answer those questions. Answer it. 7 questions are there. You need to answer it. I don't know. Answering is over. Let's check one by one the question. Question number 1. What is the ion that moves to the positive pole? What is the ion? You check your answers. I'm working the answers here. You check down the answers. What is the ion moving to the positive pole? It is Cl minus. State whether it is oxidation or reduction taking place in the positive pole. Cl minus going there, no? So confirmly oxidation will take place. Third one. Mention the reaction taking place at the positive pole. This reaction, Cl minus, liquid state, breaking to Cl2, gas, plus 2 electron. Fourth one. What is the ion that travels to the negative pole? Minha, if you like, you can put ion only they asking, right? What is the ion that travels to the negative pole? H plus, sorry, Na plus. State whether oxidation or reduction taking place in the negative pole. Na plus is going, no, it is undergoing reduction. Question number 6. State the reaction that takes place in the negative pole. Na plus accepting Na plus liquid, accepting one electron and making Na solid. Up to this one, are you clear? Have you done any mistakes? Everything is clear. Last thing I'm going to do, that's why I have stopped it here. மூடி எங்க அதுல வேற மூடி எங்க அது கம் காயும். Last one I'm going to do, you wait. I'm erasing this one. Oxidation reaction and reduction reaction I write here. Na plus 1 electron becoming Na. This is solid. This is liquid. This is reduction reaction. 2Cl minus becoming Cl2 and 2 electron. This is liquid. This is gas. My children, here how many electrons are released? How many electrons are released? 2. Here how many electrons are accepted? Here how many electrons are accepted? 1. Are they equal? Are they equal? No. To make them equal, I am taking this one as the first equation and this one as the second equation, like you write in simultaneous equation 1 and 2. I multiply the first equation by 2. Why do I multiply? If I multiply only, the electrons will become equal. Multiply this, Na plus multiplied by 2, 2 Na plus liquid. Electron multiplied by 2, 2 electron. Na solid multiplied by 2, Na solid. This is going to be the third equation. Are you clear? Are you clear? Okay. After electrons are equal, you need to add the third equation. The equations you can add only when the electrons are equal. So this equation and this equation, electrons are equal. I am adding them only. I am not adding the others. Okay. I am adding the left side one. What is in the left side? 2Na plus liquid plus 2 electron plus 2 Cl minus liquid. They are left side parts. Right side part 2 Na solid. No need to change the color. Just I am changing the color. 2 Na solid plus Cl2 gas plus 2 electron. Are you okay? Can you understand this one? Left side components are added and written on the left side. Right side components are added and written on the right side. Now, both these sides have 2 electrons. We can cancel them. To do this cancel only, we have Zuha Aslam. If it is an aqueous solution, it is aqueous. If it is a liquid, it is liquid. No need to take any confuse. UBS girls have not got the link. Oh my God. Give me 1 minute time. I sent them the link now. Okay. So Na plus liquid, 2 electron and 2 electron getting cancelled. If the electrons getting cancelled, what remain there will be here 2 Na plus liquid will remain, here 2 Cl minus liquid will remain, here 2 Na solid will remain, here Cl2 gas will remain. Are you clear? Are you clear? Remember, question is write the overall reaction. Overall reaction is this. But in example, you have to do this and show them. Okay, you have to do this and show them. You children now do it. Complete it. Done, 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 done. Everybody okay? Hello? තේරෙනවද මේ මොකද්ද අර පොඩි සයිස් තරාදිය තියෙනවාද පොඩි සයිස් තරාදිය ඒක දැන් දෙපැත්තට දාන්න එක ඒක නැහැ නේද ඒක තමයි ඕනේ මේ පොඩි ළමයින්ට මැත්ස් ක්ලාස් වලට කොහෙද ඕකේ ඕකේ ශකීල් ඕකේ ඕකේ මම වඩියට ගිහලා බලන්න ඕකේ ඕකේ right now we are coming to the next electrolysis process. Next electrolysis process is electrolysis of sodium chloride solution. Electrolysis of sodium chloride solution using carbon electrodes. What are you going to electrolyze? What are you going to electrolyze? What are you going to electrolyze? Sodium chloride solution. Before what you electrolyzed? Before what you electrolyzed? Sodium chloride liquid. Before you did, you finished sodium chloride liquid. Now finishing sodium chloride solution. So here again taking the electrolytic unit, right? Here sodium chloride solution is taken. My children, solution mean water is mixed with it. That's why we call it solution. As usual, here we put the carbon electrodes. Here the carbon electrodes. Sodium chloride will produce Na plus ion and Cl minus ion. Okay. Water here will produce H plus ion and OH minus ion. First two ions are belonging to whom? First two ions are belonging to whom? Sodium chloride. Second two ions are belonging to whom? Water. Hope you understood it. Now we are connecting the battery to the electrodes. Because of this is going to be the negative electrode. This is going to be the positive electrode. Electrode connected to the positive end of the battery, positive electrode. Electrode connected to the negative end of the battery, negative electrode. Are you clear? Good, good. Now, my children, towards the minus, which ions will travel? Attracted to minus. Who is attracted to minus? Who is attracted to minus? Positive ones. Plus is attracted to minus. So, here Na plus will travel, H plus also will travel. Am I right? Am I right? Good. Who will go to the plus? Who will go to the plus? Cl minus. Minus will go near to the plus. These two will go near to the plus. Now, these two in this place undergo oxidation or reduction. Oxidation reduction. Okay, okay, Umar, you carry on. It will undergo reduction. It will undergo reduction. Now the point coming is, there are two fellows to undergo reduction who will be given first priority. Okay? Accepting is always first to. Weaker one who will accept first, weaker ones will accept first. That is general. I will tell you a simple story to keep this idea in the mind. In my home place, Putlam, there was a grandfather who was a butcher, was playing with his grandson outside his shop. A grandfather who was a butcher playing with his grandson out of his shop. Suddenly, some thugs, can say his enemies, surrounded this man to kill him, almost like a cinema. These people were with swords. And when these people tried to attack the man had nothing in the hand, so he was just fearing with the grandson who is in the front, grandson. Without any sympathy, those people threw the sword, and that sword entered the child's eye, right eye, and the sword came through this side. The child passed away in the spot. What made this? Now the thing it is, the sword is thrown. The grandfather has to accept the sword. He made the grandson to accept the sword. Why? Why? Because the child is weaker. The child is weaker. If that boy who is just 2 to 3 years old, he was just 2 to 3 years old, small boy, my friend's son, his father is my schoolmate. Okay, my friend's son. Point it is, if that boy is in his 30 or 25 years old, if this occurs, who will be on the front? If that boy is 30 years boy and grandfather are there. 30 years boy and the grandfather are there. Now they are throwing the sword. Who will be on the front? The grandfather. Why? Because he is weaker. All the time, weaker ones are the ones put forward. They take this idea. At home, who is the most stronger person? At home, who is the most stronger person? Father, no doubt. When someone comes and knocks the door, generally these fathers don't go and see who they are is. පුතේ පොඩක් බලන්න කවුද කියලා? Wife මේ පොඩක් බලන්න කවුද කියලා? So always we put the weaker ones to the front. Always we put the weaker ones to the front. If that person who has come there has come to make some damage, first damage is to the person who is weaker than. So the point is, weaker ones will be easily accepting. Stronger ones are not easy. So although these two are going there, H plus is weaker, hydrogen is weaker, sodium is stronger. Then who will be accepting the electrons? H plus. So H plus, 2H plus will accept 2 electron and form H2 gas. This is in aqueous state now because it is a solution. Are you clear? Are you clear? Right. So my children, in this region, you will notice gas bubbles. Who are these gas bubbles? Hydrogen bubbles. Hydrogen bubble. Okay. Let's stop that story and come to the left side. Right? Cl minus and OH minus, both the ones are coming to the positive. What type of change they will undergo? Oxidation or reduction? Oxidation. Very good. Cl minus can undergo oxidation. OH minus can also undergo oxidation. In oxidation, we will pick the electron from that person. Cl minus come, remove the electron, take the electron, steal the electron, steal the electron. OH minus comes, steal the electron. So you can steal the electron from Cl minus, you can steal the electron from OH minus. We pick the electron. This is picking the electron from Cl minus and OH minus. Now, say a pickpocketer enters into a bus, steal the purse of a person. Most probably that person would be belonging to which religion in our country? Not the pickpocketer. The person who is losing the purse most probably will belong to which religion? Frankly tell that one. Okay. In Sri Lanka, a pickpocket man just go into the bus. Just go into the bus. He is someone. Okay. And steal the purse of a person. One man is losing his purse. That man would be belonging to which religion? Mostly. Chance is more for whom? Chance is more for a Buddhist. Why? Why so? Because they are the major community in our country. So when they are more, okay, in everything, they are the one more, right? In number of students who enter to the university, they are the one more. Number of people entering to the parliament, they are the one more. Number of people dying of corona, they are the ones more. Number of people dying of accidents, they are the one more. Number of, okay, so why so? Because they are the major community. They are the major community. So everything, now if there is a earth slide, who is dying more? The Buddhist community. Why? They are the one major. So very simple idea. Similarly, in this medium, Cl minus concentration is greater than OH minus concentration. OH minus will be very, very little. Cl minus will be a lot. Who will lose the electron? Who will lose the electron? Cl minus. 2Cl minus aqueous break to Cl2 gas plus 2 electron. Here also there is a gas coming. In this place there will be gas bubbles. What gas it is? Cl2 bubbles. Are you clear? Are you clear? Right. So put the details in your picture. Then answer the questions I have given you. Put the details in the picture and answer the questions I have given you. Okay, done. If so, let us do the question. Question number 2. 1. What are the ions present in the medium? Okay. As usual, I am writing the answers. These days I am writing answers. Although it is time consuming, somewhat better. So, first answer, H plus, OH minus, Na plus, Cl minus, first answer. Second one, what are the ions that travel to the positive pole? Cl minus, OH minus. Third one, what is the ion that undergoes change in the positive pole? Cl minus. Reason, concentration of Cl minus is greater than concentration of OH minus. Fourth one, what are the ions traveling to negative pole? Na plus, H plus. Which ion will undergo change in the negative pole? H plus. Reason, reactivity wise, reactivity of sodium is greater than hydrogen. Sixth one, mention the change that takes place in the positive pole by a reaction. 2Cl minus aqueous, making Cl2 gas plus 2 electron. Sixth one, mention the change that takes place in the negative pole by a reaction. Seventh one, 2H plus aqueous, making H2 gas, sorry, small mistake, plus 2 electron make H2 gas. And now it is right. Question number 7. Up to question number 7, is it okay? Up to question number 7, is it okay? Good. So coming to question number 8. Question number 8. I'm erasing it, because after you did only, I started doing it. Right. Overall reaction. I write the reduction reaction first. I used to write the reduction reaction first. AQ here. H2 gas here. 2Cl minus aqueous making Cl2 gas plus 2 electron. Here, my children, both these ones have equal number of electrons. Because the electrons are equal in number, you don't need to multiply and change the number. Am I right? You don't need to multiply and change the number. Right? So you can directly edit 1 plus 2, 2H plus aqueous plus 2 electron plus 2 Cl minus aqueous, giving us H2 gas plus Cl2 gas and 2 electron. Now 2 electron we can cancel. After cancelling, 2H plus aqueous plus 2 Cl minus aqueous, giving us H2 gas plus Cl2 gas. This is the overall reaction. Okay. Good. That is question number 8. Question number 9. Question number 9. Hope all of you have done this one perfectly. Hope all of you are clear with this work. Okay. Good. Question number 9, when you consider in which electrode the gas is liberated, anode and cathode. Anode and cathode. Okay, both electrodes, gas is liberated. And mention the gases. Anode is the oxidation place. Anode is the oxidation place. So in the oxidation place, what is the gas made? Cl2 gas made. Cathode is the reduction place. In the reduction place, what is the gas made? H2 gas is made. H2 gas is made. So this is the answer for the 9th one. Are you okay with anode and cathode? Are you okay with anode and cathode? This is question number 9. Question number 10. Is the chlorine forming reaction oxidation or reduction? Chlorine is made in the anode, so it is oxidation. Oxidation. Question number 11. What are the ions remaining in the solution in the electrolyte? When H plus and Cl minus are undergoing changes, remaining ions are whom? Na plus ion is there, OH minus ion is there. Na plus ion is there, OH minus ion is there. When these two combine together, what is the compound made? Sodium hydroxide, the compound made. Remember, this is the method of commercial making of sodium hydroxide. Sodium hydroxide commercially made by this method. Are you clear? Are you clear? Okay. Right. If that is clear, we are coming to the last electrolysis process. The last electrolysis process, electrolysis of copper sulfate solution, electrolysis of copper sulfate solution using carbon electrodes. Here, copper sulfate solution is there. As it is a copper sulfate solution, it is mixed to water. That's why it is copper sulfate solution. Here, Cu2 plus ion is there. SO4 2 minus ion is there. That is coming from copper sulfate. H plus ion is there. OH minus ion is there. That is coming from water. Are you okay with these 4 ions? Are you okay with these 4 ions? Good. Here the carbon electrodes. Here the carbon electrodes. You are supplying current using the carbon electrodes. So setup is ready. What are the ions moving to the negative pole? Cu2 plus will go, H plus will go. What are the ions going to the positive pole? SO4 2 minus will go, OH minus will go. Right, let's finish the who will accept. Who will accept? Both of them are coming to the negative. Who will accept? Who will accept? Copper ion will accept. Why? In the activity series, if you look at the activity series, who is weaker? Who is weaker? Look at the activity series. I told you that story for that one. Who will accept? The weaker one. In these two, who is the weaker one? Check the activity series. Copper is the weaker one. So copper undergoes reduction. This is aqueous. This is solid. In this case, you will notice this electrode is becoming settled with copper. It will turn to what color? It will turn to what color? Brown color due to copper deposit. Due to copper deposit. Are you clear with this? Good. So, if it is the story on the right side, really this is the cathode, because electron is accepted, it is cathode. Let's come to this. Let's come to the story of anode. Actually, in this medium, concentration wise, sulfate concentration is higher than OH minus concentration. Whose concentration is greater? Whose concentration is greater? Sulfate. Sulfate is greater. Then who should lose the electron? Who should lose the electron? If this is the situation, who should lose the electron? Sulfate. But sulfate is an empty pocket. Sulfate is an empty pocket. Sulfate doesn't brought the purse that day. Sulfate has no purse, no electron to lose. All the electrons are lost. Empty pocket. So can it further lose electron? Can it lose the purse? Can it lose the electron? No. So sulfate, if you take, it can't lose any electron. So it can't undergo oxidation. Automatically, now the electron losing chance goes to whom? Electron losing chance goes to whom? OH minus. Okay, so here OH minus becomes the loser. 4OH minus break to 2 water molecules, O2 gas and 4 electrons. This is aqueous. This is liquid. This is gas. Are you clear? Are you clear? Okay, complete the pictures, work and do the questions. Put me a done mark soon you complete it. Sulfate cannot undergo any changes. Wherever it is, it cannot undergo changes. Have you tried the questions? Have you tried the questions? And in the picture, my children, in this place, there are gas bubbles coming. Oxygen bubbles are coming now. Mark that one. Mark that one. Oxygen bubbles are coming. Okay. So what are the questions to you? And what are the answers to you? We will discuss that one in the next class. You write and keep the answer. Tired.